Thank you all for having me. I'd love to talk to you about the topic of bridging academia, industry, and innovation, in the worlds that I see colliding every day. So I've found over the last 15, 20 years that this line between research and development and business strategy is getting blurry. So for decades prior, these departments were very separate at these institutions. You either went to research or you went into industry. Mostly never the twain shall meet. Something gets thrown over the wall with a patent, and then somebody eventually commercializes it. But that line, that bright line between R&D and business strategy is beginning to fade. That separation is beginning to fade due to what I think is the rapid pace of commercialization based on advanced technology. So now that you have AI tools that can do part of the coding, literally ingest a framework or a paper and spit out some code that could commercialize it. AWS, that will allow you to run your business. These advanced technologies are sort of shrinking that gap. Even next-gen manufacturing processes for a lot of the hardware tools are shrinking that time and shrinking that distance between R&D and business strategy. And it's nearly erased in many fields like Gen AI and other computing-based fields. I heard a lot about cryptography when I just walked in. Many of these types of fields are just, the gap is gone altogether. So there's really opportunity at that intersection, regardless of how much that line has been erased. I think there's opportunity for all of us as that gap starts to shrink. And so I've come up with a framework to navigate it, but first I'm going to tell you a little bit about my story and my career journey, the values and competencies that I've used to guide my decision-making and competencies that I decide to develop further. And just some key takeaways for any level of leader wanting to keep your group, your team, your projects on the cutting edge of that boundary. So a little bit about me. I think you heard from the introduction. I did my bachelor's, master's, and PhD at Stanford University. I am a first-generation college student, so both my sister and I were the first generation in our families to go to college. My older sister studied material science at UIUC, and she works at a national lab in ORNL in Knoxville. And I was, the first one to go very far away out of the Midwest and go to Stanford. I did my bachelor's more in robotics, so science, technology, and society, but with a focus in robotics. And that was the first time that I did research where I was published throughout my honors thesis, which was really focused on human-robot interaction. So how do humans respond to that robot? What do they want to see? Do they want to see the robot disagree with them? Do they want to see the robot always do what they say? And it's super relevant to how we expect our chatbot assistant to interact with us. Do we expect them to disagree with us? Do we expect them to make mistakes? Do they seem more real or more human if they say the wrong thing or disagree with us? Some of the technical work that I did, obviously in robotics, I worked with Professor Usama Khatib on actually programming robots. And so this is a little video that I've shown to actually my third grade students class of the grocery shopping robot that I built when I was a sophomore, in between my sophomore and junior year in college. And so it would push a little cart and try to pick something up off the shelf. Does anyone do robotics? I've heard, I wasn't here all day, but I'm sure people do robotics. So this was my undergraduate project in, I think these were our collaborators speaking in French over it. So this is where I got really excited about this field of robotics and how difficult it is to do control theory. But I was always focused on the why. Right? Why would we do this? That's why my degree was in science, technology, and society. So not just the technical components, but why would we do this? Well, I was really interested in robots that help the Earth. For example, waste cleanup is a huge problem all over the world, and having robots that can help immediately pick up waste, sort through waste facilities, I thought that was really profound and a really important societal component of robotics. My master's degree, when I moved on to the master's degree, I focused in aeronautics, so more between 0 and 30,000 feet. I had a few different projects that I tested and sort of got my feet wet. One was testing how sensors can connect from a wind turbine to a computer on the ground so that we could, one, measure the speed of high altitude wind energy, and two, so that we could potentially power things using high altitude wind energy and powering computing devices from up there. I'm gonna skip past this one just to focus on the why. This was in order to design rotorcraft that could access as a turbine to harness wind energy in the sky. So you'd need to be able to measure that and measure those components if they're not fixed to the ground. So how do you make sure you can transmit from those devices? And also I was really interested in Wi-Fi networks powered by wind energy. So you may have heard of a project at Google quite some time ago. I worked with those researchers to actually try to implement some of these features. So I used, huge helium balloons that could stay aloft for days with fishing or Kevlar line and a winch system at the ground and a payload bay for sensors and routers that could immediately deploy in a disaster scenario or in an area without Wi-Fi or internet technology to create a little mini Wi-Fi cafe for people who needed to coordinate with their loved ones. There was an earthquake, there was a tsunami. How can you immediately deploy communication protocols that allowed everyone to keep in touch? So again, the why. Moving on to my PhD, I switched gears to the astro side of things. And as like many of you, it was a combination of where do my interests lie. So I was super interested in satellites, which are essentially the robots of the sky in many ways. But also there was this new professor in my department who was focusing on the space environment and satellite systems. And so as you know, there's a hybrid of who do you want to work with, what team do you want to work with, and what do you find interesting. So, and of course, the computer science of it all. So my PhD was computational plasma physics of hypervelocity micrometeoroid impact RF, which is to say, when tiny dust particles are going really, really fast and hit the surface of a satellite, they can cause an EMP. And that EMP can cause billion-dollar satellites to fail. And so why was this happening? How do we model it? And if we can model it, how can we prevent it? And the why, again, satellites help protect our Earth, right? There's satellites that are trying to track storms that are moving ever and ever more quickly. There's satellites that are, doing this data communication. And so when these things fail, let's say they fail during hurricane season, that's a huge problem. You've missed that early warning system that you need. So how can we make sure that this low probability thing that could cause a massive, massive effect, how can we protect satellites and build them better to prevent that? So many of you might be wondering, why not go into academia? Well, I went on a search, right? I gave talks, I gave my PhD talks, I looked into it. And really, I really just wanted to move incredibly, incredibly fast. And academia is just a place where at the time, again, 15 years ago, things were moving much slower. And so I ended up, this was also the time where the word data scientist was becoming a thing, and companies all over the tech industry were recruiting people out of the hard sciences and the soft sciences into this field called data science. And I think the CTO of our US government at the time sort of developed this terminology. So I was really attracted by that. I was also very interested in the why of creating belonging at Airbnb. So I joined Airbnb as a data scientist, moved into product a couple years later, and now at Roblox, I'm one of the heads of product specifically for our internal operating system. So all the tools and systems that everyone who works there uses to build these great capabilities that many of the kids and the adults really like to use. So it's super fun. As mentioned, I'm also an angel investor. I usually write check sizes from around 25 to 50K. I've invested about $500,000 over the last 10 years in early stage companies, and that's a passion of mine as well. So I'm I'm gonna walk you through the 13 values and competencies. It feels like this, career has taken many turns and ups and downs, and why this and why not that. So I'm gonna walk you through sort of the 13 values and competencies that I've used to guide my decision making and guide what sorts of skills I want to develop. So, value number 1, take the long view. To say this, I mean incorporate long-term vision, even when you're making short-term decisions. So empower innovation by thinking big and challenging the status quo. So ways that I feel like I was taking the long view are in my early background, right? So as I mentioned, I'm a first-gen low-income student. I had to envision what was going to become of a, first-gen student living in Missouri, St. Louis, Missouri, where most of the people don't go to college at all. If they do, they might go to a local university, where maybe, where my high school counselor said aim lower, right? So aim a bit lower, but envisioning that future, I found things like Upward Bound and a summer camp at Mizzou to get me introduced to these things. And finally, I got invited to MIT MITES, which was, if you know the program at MIT, it's an amazing program that really introduces underrepresented students to this world of technology. And so by going there, I was like, oh, these are the types of universities that I might want to attend. And so I was eventually accepted to MIT, Harvard, and Stanford. And of course, I wanted West Coast, because that's where all the innovation was happening. But I had to take the long view to even think that far ahead, get on a plane, go to a state that I'd never been to without, parents and family being able to come. Even in undergrad, as I mentioned, I was always interested in the societal impact of technology. And so that drove my focus, that long-term view of I think the real purpose of technology is to impact society. So that drove my focus on STS, Science, Technology, and Society, with these focus areas where it was this is really cool technology and I'm super into it. But even within that, I still had to think bigger than that. So I did a seminar in the Swiss Alps archaeology to learn about ancient technology tools. I did a semester at Spelman to understand things about technology applied to underserved communities of color. And I studied abroad in Japan to understand their attitudes toward modern technology and robotics. One of the most futuristic in my time, places you could go where they readily adopt robotics and technology, and understanding the societal reasons behind that. Much of that has to do with the aging population and not reproducing at the same birth rate. So understanding, when are people primed to accept new technology? When does it grab hold in society? And how do those things come together? Value and competency number 2, build creative solutions. So by that I mean formulate, identify problems, generate and evaluate a variety of solutions, some of which are pretty heuristic and basic, some of which are super novel, but figure out how to implement the best one. Creative doesn't always have to mean the most technical process that you could ever come up with, or the most novel process you could ever come up with. I know that's what we do in our PhDs, but when you're thinking through these things in the real world, it's not always about the most novel, it's what can be most adaptable, most accepted, and that can be creativity as well. So some examples of creativity in practice. So my honors thesis, again, in human-robot interaction. So that was my first journal publication, my first extended research. I worked with Professor Cliff Nass, who's now passed away, but he was the person who invented the Microsoft paperclip. So you see at the very early stages of human-computer interaction, and so helped guide my research. Then I went to NASA Ames, actually, and focused on building a compliant grasp robotic hand that could pick up moon and space rocks when it gets deployed on the moon or Mars. So I did that first fellowship in robotics there, and I had an advisor by the name of, he changed his name to Vitas Sunspiral. Him and his wife changed their last name. So they were super creative. I really enjoyed him. He was the most different type of dude that I'd ever met or worked with, and that was actually really what really prompted me to go back to grad school, because I was like, oh, he runs this really cool lab. He has a graduate degree. Maybe that's what I want to do. And also, he's just really off the wall. So that was my first introduction to space exploration science. I'd done robotics in the School of Computer Science, but I hadn't thought about what does that mean in this broader area. I also, before going back to grad school, joined a startup team. So I was part of 5 people in a little office in San Mateo that we rented that looks pretty crappy, but we were building something that we thought was really cool. It was called Aperture, and it was acquired by Google. So during that process of being acquired, I had to think about, okay, I have this interest in this space exploration science, but I also have this interest in startups. Where do I go next? And so part of that creativity is kind of making that decision of where can I be most creative, and I decided for now where I can be most creative is in grad school. But as you're being creative, think and act systematically. So we're all, scientists, engineers. We think in systems. Apply that to how you make decisions in your career and in your life. So examine and understand how interactions and patterns between components make up the whole. That can be the interactions and patterns in your research, but also the interactions and patterns between the industry that this relates to, where are those patterns going, and how do those components make up the entire domain? How does your funding get to where it lands? Who's approving that funding? Why are they approving that funding? What 3-letter organization? What entity? Why do they care about it? What are they going to do with it? So some systems that I cared about understanding were what is product management. So I undertook various product management internships over summers in between deciding which field to focus on. I wanted to understand, how do startups work? What is this whole thing about getting funding and IPOing? So I joined an early stage startup. I also was a course assistant for entrepreneurship classes at Stanford. I also undertook this summer, fellowship where I was at the Stanford GSB for a summer, and I, won a fellowship to be, sponsored there for that summer and learn all of these business and strategy principles for PhD students. I also did the first of its kind Harvard certificate called the HBX certificate, where you're learning basics of business strategy, accounting, and sort of the why behind where all the funding comes from. And angel investing, I sort of wondered, how does that happen? Why does that happen? So I got to know investors. I got to know investors at places like Foundation Capital that really focused on deep tech and things like silicon chips. I got to know investors at First Round that focused on early stage investing, and that taught me a lot about how do these early stage companies get money. Even as I was at an early stage company, I really had no idea why they gave us money, right? And so it took a bit more digging to understand these systems and how they all hang together. From that, I became a Sequoia Scout, which Sequoia Capital is, one of the bigger named venture capital firms in Silicon Valley. And then from that, I ended up being a scout for Uncommon Ventures, which is an AI ML fund that Sam Altman funded, and also Westbound Capital, which Theresa Johnson also helps fund. So it's just going deeper into these systems that help shape the world that we live and do research in, and that our research initiatives will end up thriving in. Another value and competency is to seek knowledge. We're doing this all the time, but do it intentionally. So demonstrate the motivation to gain knowledge and seek out information to drive improvement, specifically to drive improvement. So everything is really knowledge, but specifically in my PhD, I had to learn net new things. I had to learn about meteors, radar, plasma physics, radio frequency. I had to learn about hidden Markov models so that I could figure out how to model this plasma. I had to learn about AI to figure out how to predict what was going to happen from this. And of course, all of that together into computational plasma physics. So ensure that you're continuing to learn new things. When I became a data scientist, even though I had done this super technical PhD, I didn't know things like R and Python, right? I operated in like MATLAB and Fortran. And so somebody still gave me a job, but I had to like quickly pick up other domains. I had to learn about A/B testing, which is like, oh, that's how they make improvements to a web framework. I had to also learn about big data, like data coming off of these huge products. I thought I had a lot of data in my PhD research. I had no idea of the scale of data that was coming off of some of these web-based tools. So I had to learn about Hadoop, Spark, and Scala. In product management, I first went into product management and payments. I had to learn about things like compliance and regulation and fraud detection and risk modeling. And it's like, oh, this model also this predictive thing can also apply to this, but I had no idea that that was the case. And I also had to learn about product, even as a domain area. What does a product manager do relative, in this context, relative to other functions? And now at Roblox, I've had to learn about game design, enterprise AI, low-code and no-code tooling, and vibe coding. I've just done multiple sessions with my team on vibe coding so that we can learn how to ship something every week. Who knows what vibe coding is? Yeah. So the next value is take responsibility. Act like an owner. Treat resources as your own. So ownership in action, for me, has looked like being entrepreneurial. So before I got my NSF fellowship for grad school, when I was doing all those little master projects, I went to the dollar store to buy like Kevlar rope and like huge balloons and helium to test out these things these concepts of high altitude wind energy, drones, and low energy satellites. So I went to, it used to be this it was like a version of Best Buy, but it was like a little side version. And they had this bin of components you could buy. And they were just super cheap. And that's what I had to do because I didn't have funding yet, but I needed to prove that some of this could happen. So be entrepreneurial and figure out how to remove roadblocks. In my PhD, I was also the project manager for all of the people in our lab who were in on the same project. So even though this part was mine, someone else's part was the sensor, someone else's part was this other piece of computation. And so I brainstormed. This was during this was in the midst of one of those government shutdowns in the 2010s where, funding was delayed, but we also had to just be scrappy. I brainstormed with my advisor on how to lower the cost of getting to our facility in Germany. So we were doing all of our research experiments in Germany at a hypervelocity dust particle simulator. So how can we lower the cost of that? How can we stay in different places? How can we collaborate remotely so that we can de-risk things before we get there? I also sought out a partnership locally at UC Davis who had an anechoic chamber. So I offered to co-publish with them on testing our RF sensors so that we didn't have to pay for anechoic chambers to test out our RF sensors. And the students, even the students in the lab today, I just got an email 3 weeks ago, many years later, still asking, how did I do that? Who did I partner with, right? So these types of scrappy skills and acting having an owner mentality, not just tell me when you have funding and then I'll go do it, will serve you well. In Airbnb, as a data scientist, I took responsibility where the product manager didn't have time or resources to just kind of step in and say, yes, this is where we should go. I coached designers on best practices to iterate effectively and test incrementally, and they really appreciated that because they would redesign entire systems, and I'm like, you can't A/B test that if you're redesigning everything at once. And I ensured engineering was building for learning, building for feedback loops within the product. And so having that owner's mindset is actually what led me into product management. And now as one of the head of products at Roblox, I have to think about doing more with less and empowering others to make decisions. So that's what ownership in action has looked like for me. The next value, I would say, is actually just get stuff done. Relentlessly iterate. So I want to challenge you all to ship something every week, whether that's a paper, an abstract, a model, a feature, a data set. By shipping something every week and setting this goal for myself, I launched 20+ payments features, moving $160 billion annually while I was at Airbnb. So think about how you can deliver something weekly, right? How can you take incremental steps toward delivery in your own field? This one, we're gonna break into groups, talk to somebody sitting next to you about how you envision the future. So map out the processes, resources, and time needed for a given goal. And so I want you to take 5 to 7 minutes, talk to somebody sitting next to you about what is your current North Star goal, and how might you map out the processes, resources, and time needed for that goal. So it's in part having these conversations where you can kind of voice what you think your future is, map it out with your colleagues, your lab mates, your friends around you, and sometimes just saying it out loud will help you crystallize where you want to get. The next value that I hold dear and try to expand on is respecting the community. So I think community is greater than the organization that I'm a part of, which is greater than the individual. So always trying to prioritize pushing toward community. My way of doing that is through nonprofit service. So the reason I was flying in today is that I was helping out with a fundraiser in Boston for an organization called DevColor, which supports Black software engineers. I also have been the board chair for an organization called Street Code Academy that helps teach coding and entrepreneurship skills to underserved communities in East Palo Alto and across the country and the world. I'm also on the board of Slide Ranch that brings inner city youth out to an area called Slide Ranch, which has coastal, it has mountains, and teaches them about farming. So I really like to focus on educational organizations and career sponsorship organizations. So that's the way that I feel like I'm bringing together community and trying to bring those communities into the work that I do. Another principle and thing that I like to expand on is working with others. So seeking out and working successfully with collaborators to achieve new ideas. One example of doing that is during my master's program, when I was doing all of that research on high altitude wind energy, I met up with some colleagues in the School of Education who were researching project-based learning and the impact of project-based learning on communities that have less access to technology. So we put together a research program where we flew to Ethiopia, we flew into Addis, and we actually piloted some of our research with a local school in Addis to look at the ways that doing this sort of hands-on project-based learning can bridge together math, science, engineering, and the humanities in a holistic sense versus like sort of math is separate from this, is separate from that, is separate from that. And the research has shown that that's an incredible way for everyone to learn, but especially students with under-resourced schooling environments. And so now I send my kids to a school in the Bay Area that focuses on project-based learning. And communicate. So I make an effort to communicate early, often, and all the time. Someone in my team asked me how often I give talks. I give talks probably 5 times a year, and I've done so for the last several years, thank you. That's to clearly give and receive information, articulate and defend your ideas, and listen to understand, not just to respond. And so you can do that in your daily life. You can do that, by giving a talk. You can do that by communicating in your lab meetings, or you can do that by saying, hey, I'm going to give, like many of you did, give a presentation at a conference or on an even bigger stage. So the biggest stage where I've given, I think, a presentation was on the same stage where Steve Jobs gave many of his keynotes in San Francisco. The furthest away that I've gone is Saudi Arabia to give a talk in technology there. But I really enjoy communicating my ideas, and I learned that a lot in grad school. I had some great advisors who taught me how to basically give the TED Talk version of your research, and I've taken that and morphed that into new and innovative ways, even if I'm working on complex topics. And then motivate and grow others. So encourage others to do their best work, help them develop their knowledge, skills, and abilities. I think this is really important. It's something that I focus on. I do this by teaching. I teach Intro to Product Management at Stanford University. It's Management Science and Engineering 165, so all of my students are undergraduate engineering majors for the most part. Some of them are symbolic systems, some of them are like a minor in design or math plus econ or whatever they are, philosophy, but they all come to the class. They're sophomores, juniors, and seniors all coming to the class to learn what is this field of product management, how do I take what I have learned in my engineering courses or my math courses and think through that lens of driving product creation. And this is just a picture of me and my product team. I'm there in the back from several years ago. And then, of course, attract great people. So no matter where you are, you want to be someone who attracts great people to want to work with you. And you can do that by setting high standards for yourself, primarily, and for others, and enable them to build high quality, world-class teams. And so I think that's super important for us as leaders, for the next generation of people pushing, the forefront of technology, is to build strong teams. And so one thing that I've seen is that many of us, especially, I think I could say concretely, especially Black women, end up in a silo, feeling like they can't reach out and build a team and maybe feel isolated. And I want to encourage you, all of you, to step outside of that box and try to build whatever your team would look like or feel like. And occasionally it can feel challenging, it can feel harder when you're not sure who you can trust or who you can go to, but I would encourage you to step outside of that and be a little bit vulnerable to try to build that team. And then, of course, all of this is driving toward creating an innovative environment. In whatever environment you move through, you want to be the person that's eliciting big ideas from the team and encouraging big bets on those ideas. And with that, I will end there and see if there are maybe one or two questions.